Hello. So I'm Peter Vale, Program Manager at Microsoft on the Windows Mixed Reality team. And here with me today is
Dirk van Welden, founder of iIllusions, who we made Space Pirate Trainer. I do mostly the technical side, some gameplay programming, and shaders and optimization is also my cup of tea.
Awesome. We're here to talk about Windows Mixed Reality today. So let's get started. We're going to go through this in 4 basic sections, starting from very high-level stuff, just to introduce you to some of the stuff we're talking about, and then getting deeper as we go. Basically, we'll do some introductions into what we're talking about here today, talk about porting your applications for the Microsoft Store or Steam VR, and then going to some tips and tricks to make the best use out of our platform, and then some of the deeper details about performance optimizations. If you managed to get to the Intel talk that was earlier this afternoon with Dirk, then they went, if you would think of it as like a number 5 on that list, they went even deeper into sort of some of the tools that you can use to get more information and really work on those optimizations to get a large range of different PCs that you could use. So we're going to go through all those things today and try to keep it going quickly. So we'll hold questions to the end. And just a reminder, if everyone could just make sure they've silenced their cell phones. We're going to be recording this so that we can put it up later. And yeah, make sure we don't have any weird ringtones. OK, here we go. Getting started. Right, like I mentioned, we're going to do a quick introduction into just what is Windows Mixed Reality. If you haven't yet had the opportunity to try headsets and controllers that we have, I recommend that you go check that out at the Microsoft booth that we have. We have some demos that are there right now. It's pretty cool stuff. And then we're going to go through some of the examples there, and then we're using Space Pirate Trainer as a case study of some of the techniques and process that we went through to take the application that you already had and port it to our platform so that you can get some real examples of how to do this. First, just at a high level, Windows Mixed Reality, of course, the headset is 6 degrees of freedom, so full motion, full range that you can move around, room scale experiences, seated, standing, whatever you need. But the real interesting key here is the inside-out tracking. So it makes it really easy to set up. You can just put it on wherever you are, go from your office to your home to your coffee shop, whatever you need. As well as the motion controllers are tracked from the headset, so they also just, it's just one system in a whole that you can use anywhere. Really easy to do. So I know you guys have used that effectively in your development flow.
Yeah, so at iIllusions, we do some kind of game jam. Our company is set up that way, so everyone works remotely, and every month we come together for like 3-4 days in a place in the Ardennes. And so it's kind of a hassle to bring all the headsets with you, right? So setting up a Vive is perfect tracking, but you need the base stations. Oculus, you need a lot of USB ports and the cameras. And so actually, we found out that the headset that we're bringing most to remote development is just a mixed reality headset, because it just has one USB, one HDMI, and it just works everywhere. So it's perfect for demos. Also, the flip-up visor, pretty interesting if you're a programmer. So you just flip it up and start working again. So if you're a VR developer and you're programming gameplay, there'll be lots of switching and lots of flipping of your visor.
Great. Yeah, it's pretty convenient. All right. We have 8 partners with devices in market today. So you have a great range of choices available to you as a consumer. Everybody's head is slightly different, so find the one that is most comfortable for you and you're good to go. All the devices are based on 2 reference designs, so you'll either be using a device that has LCD displays or a device that has AMOLED displays. And of course, realize that there's some differences there, so as a developer, you might need to be thinking about what the field of view difference is, or the number of pixels for your performance, or even color and things like that might be different between the 2 different screens. Before you get started, of course, you want to make sure that you have your development PC set up effectively with all the things you need. Make sure you have updated drivers. There is, of course, a difference between a consumer PC and a developer PC in terms of what we recommend, because you're going to have more than just the mixed reality portal running. You'll also be using your dev tools at the same time. If you want to make sure that everything meets spec, then there's an app that you can download, the Windows Mixed Reality PC Check app, and it does basically what you see on the screen there. Brings up a list of all the things you need and gives you some check marks if you pass, and otherwise it'll tell you what is maybe needing to be adjusted. A note, if you are using something like a notebook that you are going to require some adapters for, if you're using an HDMI adapter, then you'll want to make sure that you have some adapter that supports 2.0 if you want to get a 90 hertz experience. If you're using an adapter that only has HDMI 1.4, then you'll have a 60 hertz experience. Likewise, Bluetooth 4.0 is giving you the best experience for your motion controllers. All right, Dirk, your controller.
Yeah, Space Pirate Trainer for people that haven't heard of it. It's a game for VR. So a few facts about Space Pirate Trainer. So it's actually, you're on a platform, you try to aim at droids and they attack you. You have sort of a bullet time effect when bullets fly around you. So you can physically dodge them. So room scale was super important, the controllers and the tracking itself was super important. So, if it goes to the, yeah. So a few facts. So Space Pirate Trainer was a launch title back in 2016 for the HTC Vive. Launch title by the end of that year for touch, and now was a launch title for Windows Mixed Reality as well. We've been in early access since Vive launched. We hit 1.0 last year in the end of the year, and so we sold more than 100,000 units on all of those platforms, and still used worldwide in a lot of arcades because it's just an easy way. Just give them the controllers and the headset and they start playing, and so they don't need to know about the depthness or the depth of the game itself. So yeah, that's Space Pirate Trainer. So why did we port to universal Windows platforms? I'm going to use UWP. So actually, we went to the Seattle office at Microsoft, and I was actually worried about the controllers, that they weren't tracking really well. So
yeah, you were concerned before you even got to try the platform. Like,
I think
it has to be just right. So
yeah, a lot of devs
I want to make
have
sure it's going to work.
Feeling. So they booted up the Cliff House and watched it for 10 seconds, tried like moving around my back and didn't experience any problems. So I had a few concerns, but actually Microsoft solved all of those in the meantime. We had it up and running in 3 days. So I had 1 day I prepared in advance because we already did the Vive to Oculus port, so we had some setups already done in our project to do multi-platform compilation. So we had it up there running in 3 days, but we were aiming for the same minimum spec as a 970, so that's the same spec as the Vive and Oculus is aiming for. So there is a huge market because there's a lot of brands pushing this. HP, Asus, Lenovo, Samsung, so they're all going to push this brand. And at the time, there was almost no content available, and also the experiences themselves weren't available for even for mainstream users. It was worse because most of the time you need a beefy PC and a decent video card. Also, if like mainstream people or people that buy a headset for the first time, they put them on and they see like the first area they come into, it's the Cliff House, and they see a box with Windows, they click on it, that's the Windows Store. So if you want to be on there, the first initial point of sale is on there. So that's why also we put Microsoft or Space Pirate Trainer on the Microsoft Store.
Great, nice segue into porting. This is our second section, where we're going to talk about just what you mentioned. So, taking your existing application that you might have already done for other platforms and then porting those to our devices and our platform gives you a couple of options here. You have, if you go and build for the Universal Windows platform, that gets you into the Microsoft Store, and you can also get your application into the Steam Store. So you've got two avenues to reach your audience. And then also realize, of course, that you've got a variety of different PC hardware out there that works with our devices. So what most people would experience as like a 90 hertz experience if they're using a PC that is sort of considered, let's say, VR ready, they'll be getting the full frame rate and full resolution. But our device also works with other class of PCs as well. where you get what we call a 60 hertz experience. So it's a slightly reduced frame rate and resolution so that we can maintain a stable experience for the user. And that's, an example of those are integrated GPU machines. So it gives you a much wider audience out there that we can support. So the first thing we're going to talk about is updating your app to work for SteamVR, for the Steam store, because most likely you've already got an app in the Steam store if you're starting from somewhere already in another device. So really the only things you need to worry about are your controllers. So we have basic APIs and assets that you can use that give you the 3D assets as well as the 2D assets so that you can use the right ones so that it matches, the device that you're holding in your hand is going to look correct. And then also realize, of course, there's a few reserved commands that you need to think about. There's one for getting back into the Steam dashboard, and there's one for getting back into the Windows Mixed Reality Home. We recommend that you try to match the teleportation model that users are going to be familiar with from the Windows Mixed Reality Home, if you can, because that'll be just obvious to them. And then one note I wanted to call out was haptics. So today, if you're just using the regular Windows that's available to regular consumers who aren't Windows insiders, haptics doesn't work yet in SteamVR, but it is in preview right now, so that it will be available soon. So if you want to test your application, you can go ahead and do that. And of course, you want to make sure that you enable that logo to show up so people know that this platform is supported for your application. How did you do that for Spacefire Trainer?
So what changes did we make for the SteamVR version? Well, actually, not much. Like most of it just works out of the box with their emulator. So we did change the UI to use the mixed reality controllers. We adjust some of the controller input. So the Vive has a touchpad. The Oculus Touch has a thumbstick, and actually the thumbstick selection, like from the way you choose weapons, is super easy with a thumbstick. And so a lot of users were asking, why isn't this working? So we just added support for that as well. It's just an extra axis, or you do direct input. So you can, that's one of the only things that we actually change gameplay-wise. And then just enabled Windows Mixed Reality support. So let's take a look at those. So the left side is the Vive controller. We had our own artwork, so we just recreated the same one for mixed reality, and we just changed them based on what headset is attached to. So how do you do that? Like, how do you know if it's running on mixed reality or if it's running on Vive? So this is more technical, but there's if you're using Steam API, you can just check the instance, and there's a string called HMD tracking system name. If it has any form of, like, if the string holographic is in there, you're using a mixed reality headset. So once you do that, you just put a if statement, and you can set a flag or do specific functions for Windows Mixed Reality, which is, for example, swapping out those images. Final thing, enable WMR support in the Steam store backend. So just go to partner.steamgames.com if you know that, and then you go to the store backend. There's actually a section called virtual reality, and you have to unhide support, like hide Windows Mixed Reality support, make sure it's unselected, and there will be an icon on the store after that. So yeah, that's all we had to do to make it compatible with SteamVR.
Great. All right. So that was how you take your existing application that you may already have in SteamVR and update it so that the Windows Mixed Reality device and platform are highlighted there properly and use the right controllers. Now we're going to talk about how do you create a UWP application for Windows Mixed Reality from scratch. And so Dirk had a great idea. He said, I can do this in 1 minute on stage. Thinking, OK, let's minimize chance for error here on stage. Let's do a video of it in advance, but he'll still talk through it. So one thing to note, we're going to be using the Mixed Reality Toolkit as a source of some components that you can pull in, and that makes it really easy. So the Mixed Reality Toolkit has, created by our team as well as a great community that's out there working on this, has got a number of different examples, samples, and tips, tricks, and techniques that you can go up and take a look at now and just use them in your project however you need to. All right, Dirk, you got a minute.
So assume you already downloaded that, and also we rented the fastest PC in the world just to make it run in 1 minute. Not true, but no, still. So yeah, you have a basic project, not XR enabled. There's a camera. Just change the build settings to Universal Windows Platform, and once you do that, it switches all the assets to Universal Windows Platform. Then you need to enable XR, and so you just go to the player settings, and there's a button called XR settings. Make sure that Windows Mixed Reality is enabled. So if you're not on UWP, it'll not show up. Then start importing the Mixed Reality Toolkit. So it's a package that I already downloaded there. Let's just go to the right folder. So there's a bunch of stuff in the Mixed Reality Toolkit. So I have a library there. External, you go to Unity packages, and you just select the right one for the Unity package. So once that's imported, you'll see a new folder there, and there'll be a new, here on the upper side, there'll be a new menu item. So in that menu item, left, like there are a bunch of packages. In the menu item itself, there's just configure and add scene configuration. Just select all, apply, and it just adds everything automatically. Just have to change or delete your current camera, and just press play, and it should work instantly. So with those import scene settings, even the controllers will show up, and they will track automatically. So yeah, that's it. Should be around 1 minute.
There you go. Pretty easy. Nice. Great. So you know how to create a new project really quickly and really easily and make it work with Windows Mixed Reality. Let's talk about actually porting your existing project to UWP, which has a few more steps, a little bit of more work that you'll probably have to do because you have more detail. First, of course, you want to make sure you have updated your software to everything you need to develop. Windows 10 Fall Creators Update is the right starting point, and you'll need to make sure you're using the versions of Unity, Visual Studio that are listed there on the slide, and some applications that you can use to make sure that when you do have everything running, it'll be able to go into the Microsoft Store. We've got the Windows Applications Certification Kit. People call it WAC. You'll want to run that early and often just to make sure that everything is going to work. And then the Portability Analyzer can help you to find other issues if they come up as part of your submission process. Then you're going to want to update your middleware in your project. So we worked with a number of different developers back in the fall of 2017 as we were launching this product and helped them to get their apps ported over. And plugins and third-party stuff, and that was a lot of times where most of the issues would sort of crop up. Since then, there's been a lot of updates to some of these plugins that are out there. So we recommend you go and update whatever you're using in your project to make sure it's the latest so that it supports UWP. Or you might have to do a few workarounds. IL2CPP is another option for you, and that's a really effective, really great option that Unity recommends. So it makes it easier to get your port and avoid these problems with plugins. So we recommend it. Of course, you want to target your app to use UWP, which means that if you're using any other platform-specific or device-specific services like high scores and matchmaking, for example, if those aren't going to be supported in the Microsoft Store, then you'll need alternatives for those. And target your app to run Windows Mixed Reality like we described in the 1 minute video. I think that was pretty clear. This device can work in a number of different experiences where anywhere from seated to standing or room scale. Depending on your application, you might actually have an experience that goes from one to another. So you can use some of the APIs to determine where the floor is, and that helps you for standing and room scale experiences. Seated, you don't need to worry about that as much. Likewise, boundaries, those are provided by the system if the user has set them and they have those turned on. That will help them to know that they're not reaching an area that's unsafe. But you could also try to make better use of those boundaries in your application, depending on what you have, so that things are within reach in a reasonable way. And then updating your input system. So there's a few really great resources online already that you can go and take a look at. I didn't mention this, but at the top of each of these slides, there's usually a link to some of our documentation. Recommend that you go up there and take a look at those things. That's going to have the latest updated information all the time. So it's tiny right now, but after the fact, when you have this slide deck available to you in the vault, you can go look at that later. Those 3 links are great references for the input system, both on our documentation as well as Unity's documentation. And then finally, you're going to want to build and deploy from Visual Studio. Using Unity and just doing testing with play in the editor is great, but it doesn't really expose the full pipeline that you have to go through to make sure that this is going to work as UWP. So definitely make that part of your workflow. And then you end up with your application running in the Mixed Reality portal.
Yeah. So yeah, what changes did we make? Is my mic still on? Okay. So what changes that we make? So first of all, since we're using Oculus and we're using Vive and Steamworks and Steam and all those high score things, we need to make sure that we were removing all the DLLs and libraries that we're using. So we removed them from Steam, Oculus. Let's check out the differences. For example, on the Steam version, we have a bunch of APIs. Even Oculus is still in there because we're using Oculus natively. On the UWP version, we just have 2. So one is for the gamepad, Xbox gamepad. The other one is just a particle plugin. So there are 2 ways to do this. The first is not the best way, but that's the way we did it. Like, we had a dedicated machine. We just removed the DLLs and made sure that Git did ignore it. So the way you should do it, according to Unity, so you use your import settings, just select, I need this, and this DLL, and it'll just take out any DLL that you don't want in there. So once you do that, you probably end up with a lot of warnings and errors. Because some of the components just want access to, for example, the leaderboards. So what do you use there? We use platform-dependent compilation. There's a bunch of documentation out there by Unity, so make sure to check it there. I'm going to do a quick recap. So I just set, for example, a scripting symbol. We used MR platform. You could also be used Oculus platform. And we used Steam platform. So those were our 3 ones. And also had an offline version for a version of SpacePipe Trainer that shouldn't go online. So that's how we did it in the player settings. And then if you take a look at the code, it's just checking which platform you're on. And then we do an if statement. For example, this is for input. So we were using raw input data. So for Steam, we had one for Oculus, and then one for Windows Mixed Reality. And then we did something platform specific. Now, it's just a unit. It's just an input example. The most common that we'll use in there are Steam VR API, Steamworks API, and Oculus API. So yeah, that was a bit of work, probably the most work for porting to UWP. Since you wanted a big project that was compatible with all those platforms, we just needed to swap out or just needed to change the project within a few minutes to another version. We wanted to keep it in the same scene, and so we had this kind of setup. So we had all root nodes, one for Steam VR, one for Oculus, one for Microsoft Mixed Reality, and you see they're all alike, so they all use a camera and a controller, and underneath the controller we have a prefab for the weapons. And so based on the model or the type of system, the platform that you're using, we just enable the right one. So you can use xrdevice.model from Unity's documentation to see or to get what model you're using. So that's super important and very easy to use. And then the last thing, actually when we were doing the ports, the Unity input system wasn't available yet. And most of the time we create our own input systems because they tend to be slightly faster. So we use native APIs for the input. First of all, on the Unity documentation, there's this whole mapping. So you can use axis, get button to get specific buttons from the controllers, or you can use raw input data. And I'll have some code for that as well. So first of all, you need XOR WSA input, and once you get that, you get an input manager, and you just read it out. It gets some source states, and out of that source state, you can, for example, get the handedness of the controller. The second example is one is a trigger press, like select press, or just get a thumbstick value. So That's the fastest way we use it like that. We use it like that because we write our own, for example, trigger input system and hair triggers. So yeah, that's most of it for WSD.
Great. So yeah, just to note, of course, yeah, like you said, the Unity input model that they have is definitely recommended. It makes it really easy to do and cross-platform really easy. But yeah, if you want to do some interesting things with input, then we definitely have access at that level with the APIs provided, so you can dig in and do whatever you need. So we're going to get into some specific tips. We'll start with general tips, but we have some specific tips after that with how to really optimize your application for Windows mixed reality. Because as you notice, like, you know, with this headset and these motion controllers, there's a lot of things that are similar to others that are out there, and there's also some unique differences that you'll see with ours compared to others. So depending on where you're coming from, you might have different adjustments or different tips that you might want to take advantage of. So as an example, if you're porting from Vive or Rift, of course, those are also 6DoF or 6 degrees of freedom. So that means that you can pretty easily port your experience from theirs to Windows Mixed Reality. But if you're coming from something that's more of a 3 degrees of freedom system, say Gear VR, even though you might think that, great, I've got this application that's designed to run on a mobile device and it's going to be easy to port to different platforms and then have them run on as wide of a PC configuration as possible, you have to consider, of course, that, well, if people are used to having a fully movable, fully articulated experience that you don't have with yours, there's more work there. So, you know, we had some partners that came in trying to port their applications from Gear, where they realized they had to, you know, suddenly have motion controller support to make their experience make sense to people who are used to having that when they're using this system. Motion controllers. So like you can see, our motion controllers have touchpad and thumbstick, so depending on where you're coming from with others, you've got those available to you as well. You know, like Dirk said originally, your concern was, well, what happens if it's out of the field of view? Like, is it going to be able to do what I need to do from my experience? And in general, yes, we have a lot of great examples and samples that you can go up and take a look at for things like throwing or, you know, grabbing something from behind your back. Those are, you know, very common experiences, and those work great. As well, you might consider that, you know, with other systems that have external trackers, you know, if you've got something that you have to, maybe like an ammo clip that is on the ground that you have to crouch down and pick it up, well, if the tracker is now blocked by your desk or something else like that in your room, then maybe it can't see it. But because our device, generally whatever you're picking up, you're actually looking at your hand when you're doing it, and we track the controllers by what you can see, then you can do those things. So it's an interesting trade-off between some of these different platforms that you can consider when you're using this. Likewise, there's the opposite of that, which is, you know, for other systems, it might be easier for them to track the controllers when they're really close to your face. In ours, if you put your controller really close to your face for, you know, say aiming with a bow or something like that, it's not able to track it as accurately, so you have to consider how you're going to do that in your application. And then we also have, the system provides the capabilities to track the controller if it's out of the field of view for a longer period of time. And I think Dirk's going to talk about, you know, some examples of that for Space Pirate Trainer. Behaviors, of course, like we mentioned at the beginning, the flip-up visor makes it really easy for people to get in and out of being immersed versus, you know, part of the real world. So you want to make sure that you have good pause states, or, you know, when you lose focus from your desktop to something else, just to make sure that you've got a good trade-off there or handoff there in that case. And then, you know, because you can go from seated to standing to somewhere else in your room, make sure your experience has good recentering logic in it, because you might need that so that you can have a good play session wherever you happen to be in the room. All right, so now we're going to go into some specifics with Space Pirate Trainer.
Yeah, so same thing, motion controller, the stability, smoothing, and recoil. I'll talk about more. The angles of the weapons that we're using, I'll talk about more, like in the next slides. But throwing, for example, we're using electric net, so we never had to change anything. The behind the back just worked out of the box, so we didn't have problems with that. And then holding blasters out of the field of view while walking. So we were very concerned that people, if they're moving really quickly and you're holding a shield here out of field of view and you're looking the opposite side, and you're actually stepping in a certain direction, that the shield would just like remain here floating. So, but that actually wasn't happening. So what Microsoft implemented is then when it's out of field, they lock the controllers to your headset. So if you're walking around, they'll still follow you.
Right,
so
you still get the full angle information, so that if you're doing anything like that, but if it's out of field of view long enough, it will lock to where your body is, so you can move along with it, and then as soon as it gains tracking again, it gets it back.
So haptics, we spend a lot of time on haptics for all the different systems, and the weird thing is that every system uses its own way to contact or to communicate with the haptics. So for example, Steam uses, or Steam VR uses amplitude and frequency. Oculus, you can add audio clips, and Microsoft just has set the amplitude or set the amplitude for a certain amount of time. So you can actually implement the audio thing as well. So you can just read out an audio file, just check the volume, and then just do the same thing, like just set the amplitude of the controller. We ended up creating some fade outs, and that was actually one of the easiest way to implement haptics. So we just had a fade out function that worked on any device, also with frequencies. So you could have different kinds of vibration in them. Then testing the build, of course, in Unity that we're using, it's super easy to just click play and start playing it. But actually for performance testing, we found out that there's a lot of performance differences between inside of Unity and our Visual Studio build. Also, all the different headsets, not all of them, but they have kind of a different gamma and color. So especially the Samsung, because of the AMOLED, it has a much deeper blacks and the contrast is much higher. So also anti-aliasing, because of the big contrast, aliasing is much higher than on the LCD screen. So that's something to take care of. Motion controller, stability and tricks. So one of the first things we noticed, and that's the case with any other system as well, it's, for example, the railgun, which it needs to be super accurate, right? And so you charge it up, and when you release it, it launches a beam. But just releasing your finger added some kind of rotation on there. So the problem was that you were always aiming a bit too high when you were releasing it, so it didn't feel natural. You don't have the problem if your controller is weighting, like if it's heavy, it's probably because they're so light. And so what we did, we ended up with a trick, and those are the real values. So whenever you go on a droid, we lock it for 60 milliseconds. And after that, if it's less than 5 degrees off from releasing it, it's always a hit. And so it felt so much better. So it's kind of a cheat, but it doesn't feel bad. Like if you're for more than 5 degrees off, it's still a miss hit. But it was a very cool trick, and it works perfectly. So if you're feeling like it's not doing exactly what I want, it's not hitting enough, like this is a good way, it is a good trick to do this.
Cool.
So all these controllers, you can see I've photographed them all in the same angle, and just to have a look at what the angle differences are. And there's not so much difference between the Microsoft one and the Oculus one, but the Vive has a totally different angle. And so how did we deal it with weapons? Because everyone wanted their own feeling. So actually split out the weapon in two parts, like we have the handle, and now we have the barrel itself, and users can just configure that themselves. So if you have different techniques like H3 VR, they use this kind of hologram, and so you can like change the model based on your hologram. So there are different techniques for it. This is what we use just to make every user happy, and also because of different angles, that everyone was happy with their angle. So this is a big part, I guess.
Right. One thing to note about the angles, I think we had a slide earlier that noted that we have two things. One is grip pose and one is pointer pose. I didn't really talk about that on that slide, but I'll mention it now. So grip pose is so that you can align digital representation of the controller to match how you'd have it in your hand, so that it'll match the grip. Pointer pose is more for something where, if you're trying to select something, the beam that would go out in front of you to do some selection, or if you're using something in your hand that kind of is that type of orientation, it gives you two different options that you can align your assets to what is in the user's hand comfortably, and then you can adjust it for custom things like your blasters, depending on what the angle is. So now, performance optimizations. We're going to go through a few examples here. Like I mentioned earlier at the beginning of the talk, if you're looking to get very specific details about how to use things like some of the perf tracking and tools, recommend taking a look at that Intel talk that happened earlier today. They go into even more detail than we're going to cover here about those things. But we have a toolkit and other examples that I'll give you some good examples around how to bucket different settings so that you can adaptively or dynamically choose which set of performance optimizations you might want to turn on or off based on what your PC spec is that you're running on. Asset optimization, we're not going to talk about that too much here because it's kind of obvious. Obviously, everyone has different unique things in their project that they need to think about. Sometimes it's just the number of things you have. Sometimes it's the number of polygons that you have in a particular thing. Whatever it is, that's obviously one of those areas that you need to be thinking about when you're optimizing for something like the 60 hertz experience, right? And so that's what most of these optimizations is about, trying to reach the widest possible range of PCs that are out there. With a number of different cool tips and techniques that we're going to share with you today. Shader optimization is a huge one. So I'm going to go into some example on that. And then the last one on the list there is kind of neat. I think that's a cool trick that Dirk is going to share. But otherwise, everything on there is great, just general guidance. And we'll go into some specifics now with Space Pirate Trainer.
Yeah, so just like Peter just said, if you really want to get into detail, we did one with Intel. It's like it uses GP and other tools to get into specifics of shaders. We're going to be pretty high level on this. So where do you start searching for performance optimization, and what do we do? So first of all, you can see if you're using a mainstream or a high level PC. So by default, it's running on 1440 the resolution. If you're using a mainstream, it's going down to 1280. So once you know that, so you can check like in Visual Studio, is my resolution lower than 1440, then you know in Visual Studio that you're running on a mainstream PC. And in Visual Studio, you can then just do it a little bit lower. Like you can get that extra kick out of there, but actually it's only use it as a last resort. Like you don't start off, any game will run great in 256 by 256, so you can run Crysis 3 on all of these little machines. So use it as a last resort if you still want some headroom for getting to the 60 frames or 90 frames per second. So first of all, checking out if it's GPU or CPU bound, obviously number of enemy objects, be careful with shaders, texture resolutions, that's all very GPU-like. CPU, we did a lot of raycasting for every bullet on the scene, and we had hundreds of those, so it's pretty heavy. So we used kind of a level of depth, so the further the bullets are, the less they raycast, and the longer the raycast is. And the only negative or the only downside is a bullet might hit a target 3 frames in advance, but since it's so far away, no one ever sees it. So everything as close to you still is doing the same thing. And it's actually 4 times faster that way. Also, we search for objects like, for example, the audio pitch. Searching, don't do it, or at least as possible, make lists, super important. We actually had that problem, and we're experienced programmers, and we also had that. And of course, a number of draw calls, super important. Be careful with how many things you draw, and make sure you can, for example, use instancing. So the most obvious is all, low versus high quality environment. So left one is on the 620, right one is high quality, or almost the same one, but with a high environment. So you can just see the jump gate, for example, at stations. On the platform, you see different lines. Colors are a bit different, so that's one of the basic, the most basic optimization that you can make, actually. But it helps because it reduces the number of draw calls. Then we have half lambert instead of standard shader. So Microsoft has a bunch of optimizations. They have shaders available on their mixed reality toolkit. So they have half lambert, and that's like 4 times faster than a standard shader. So use it especially for the things that are like taking up all of your pixels. So that's most of the time that's a floor, right? So we looked at the floor. We changed that and it ran so much faster. So in this image, we used the same post effects. We just changed on the larger platform. We just changed from standard to half lambert. The only real difference are the lighting at the edge and the reflections. See, that's, but it runs like so much faster, and it's still like, okay, this is something I can live with. That's something that you have to deal with your artist. So it will always be kind of a give and take. So yeah, so we thought it was all right. We went with it, and also not alone for the floor, like the whole environment, everything that's small enough, we changed to a half lambert instead of standard shader. And also post effects. I like dropping post effects on there to make it pretty. Especially in prototypes, and then they end up being there in the final game. And then we optimized it, make it run always on a 970. And then for a 620, we couldn't do it anymore, so we had to rewrite everything to just use one render call. And so if you look at the differences, we use 2 cameras, one for the high quality, one for the low quality one because of all the settings. And so if we look at it into detail, high quality one, we're using a blend for when you get hit. There's an amplify bloom, RGB split, fog effect, brightness contrast gamma, and you'll be asking what's optimized about this. Well, actually in those shaders we all changed them because there is a color lookup table there, so it uses the same call here at amplify. We use another color lookup table. Use it twice just to create some sort of HDR effect for the glow. So we try to recolor the glow as well. And if you take a look at the low quality camera, it's just one component. Using all these features, one draw call, the results of this is left one high quality camera, in total 38, and then the camera image effects, 17. Bloom takes like 5 or something. And then you have the low quality one, and you see image effects here, 1 render call. So, and it runs so much faster as well. So. It's a bit technical. I can probably share some of the stuff or share the shader itself that we used. Feel free to tweet me about it, and I'll try to make it open source.
Great.
So this is difference, same materials, but with a low quality camera and a high quality camera. Same materials, so we're still using standard shaders just to show what the difference is between the post effects in both versions. So high quality, mainly it's the blooming, and color correction isn't that like awesome as the other one, but still something that we could live with, so we decided to implement it. Next frame. Okay, so for example, shaders that you use a lot on the screen, for example, in our case, lasers, they have a glow effect. Glow effects shader actually, and it has so many instructions, and once the lasers are like 5 meters away, you don't see the difference between an unlit shader and the glow shader anymore, so we just swap them out. It's like you could also say we can just add other game objects into there, but just the way we were doing like keeping lists and stuff, it's what's much easier to just change the shaders and materials dynamically. And the last thing, so you have the skybox, that's super interesting because it takes such a big part of your screen, and then you have the floor. But you also have to look at dynamic objects. Like for example, our shield, a lot of people were playing it like this, and so it filled the whole screen. So if even that shield shader has a optimization process of like 10-20%, which is not so big if it's just a tiny object in the background, but if it's in full screen, it makes a huge performance impact. So you had even people playing with 2 shields, and you have 2 shields next to each other. If you do a 20% faster, it's just a huge performance increase. So be careful with things that could be close to your face and try to optimize those as much as possible. We even had a different kind of standard shader from Unity, so we removed some of the keywords, for example, just for that 1 extra %, because we were using the shader so much. Very obvious, but still, lighting in VR, we use forward lighting to use MSA in high quality settings. In the 620 version, we used 0-point lights. And you can actually also, we're using light probes, but still, it also takes a hit. So make sure if it doesn't need light probes that you can actually set it in the mesh renderer to not use it. Single pass rendering, super important for the CPU because, like, for example, on a 620 in a Microsoft Surface, it goes to thermals and it goes to throttling either GPU or CPU. So you have to make sure that both of them still have some headroom. So single pass fixes a lot of stuff for your CPU, but it has some problems with older shaders. Most of the time, just updating them actually makes a big difference. And if it doesn't work, there are some tricks on the Unity forums that show you how to rewrite those, or it's just, most of the time it's just one extra keyword. Texture resolution, super simple. It's probably one of the fastest way to test if that's the problem with your project. You just use half the resolution on your project, and for a 620, texture resolution is super important. So make sure you do that, especially for the skybox. Our skybox went from 1 millisecond to 0.2 milliseconds of render time. So it's a huge difference. It's also such an amount of pixels on your screen. Draw order, super obvious, but still Unity does a good job, or standard, like all engines do a pretty good job doing draw order, but only for static objects. So if you're using your weapons, for example, or if there's like objects moving, and you're sure they'll always be in front of the screen, like make sure that they always draw first. So if you first draw the background and then the environment and then the weapons, it just redraws every pixel. It's just GPU working for nonsense. So make sure you can change that. It's actually pretty easy. So you have a bunch of render queue, and it's actually already a list so you can select from. Just go into materials, and just say like I want to be in the environment render queue, but it's tiny bit faster. We used -100s, and you'll be sure that the weapons are always drawn first. And one super cool trick that like even Intel said, what are you doing? But it works so well. We don't use MSA in 620 because it's too slow. So we actually blur our GUIs in front, like just in Photoshop. And right one is a 1 pixel square, left one is just blurred slightly. If you rotate those in your game, you can see the right one is super aliased and the other one is like almost like, it looks like we're using MSA, right? So we did the same thing with fonts exactly. So our font texture was just a little bit blurred, and so all UI just looked much better in the end. So that's a pretty weird trick, but it works and it doesn't use any performance. So use it. So in the end, results for this 90 Hertz experience, left one. Right experience was the version that's now running on the Intel NUC or a Microsoft book. And actually the first time I said to my QA leads, like, test this out on your little XPS Dell notebook with a 620. I was like, no way it's ever going to run Space Pilot Trainer, but they plugged it in and it runs smoothly. So the only difference is the level of quality. You can see details into resolution, but because there's certainly a difference when you put them on. The resolution is slower. The 60 Hertz, 90 Hertz makes you feel that you're not looking at a screen. 60 Hertz, you still you see that you're looking at a screen. So that's the main difference between 90 and 60 Hertz. But still, we could live with that part. That's a worst case situation. And then the best case situation is if you look at this screenshot, we're making sure that everything that's very close to you is using the same shaders or almost the same shaders, like we're using standard here. The head of the mothership is also using standard shader because it has such a big impact. So those are the two things that you notice, right? But all the rest is actually Lambert in this screenshot. And you can see a bit like the color correction is a bit different and the glow is different, but something that we could live with so that people with 620s could also enjoy a Space Pilot Trainer. So yeah, I think that's it. It's pretty high level, so you can always come and talk to me if you want more details or if you want technical information. So yeah, thank you so much for being here.